A very good morning to one and all. Today we are here for another session of our teaching. Today we will discuss the topic Doppler effect. For that, we have our team, myself Aparna AH.
I am Deepika D.
Myself Aswathy.A.
Okay, now we will move on to our topic Doppler effect.
Good morning, all. Today we are going to deal with Doppler effect. Do you know what is the phenomenon Doppler effect? It's a very interesting topic. What do you observe when you throw a pebble into a body of water? Aparna teacher, can you answer?
I think we will be observing waves.
Yes, right. We can observe waves forming in the water. And Doppler effect explained why we perceive a change in frequency when the wave source approaches or retreats from us. Doppler effect is the change in frequency of a wave for an observer moving relative to its source. The observer observes an upward shift in the frequency when the wave source is approaching, and also a downward shift in frequency when the wave source is retreating. And Doppler effect can be applied to all the waves, including sound waves, light waves, and water waves. Today we are going to deal with Doppler effect in sound waves. Before going to the concept of Doppler effect, we have to first of all understand wavelength, frequency, and velocity. What do you mean by wavelength? Wavelength is the distance between two successive crests of a wave, especially the points in a sound wave or an electromagnetic wave. And the formula for calculating lambda, that is wavelength, is equal to nu by f, that is speed by frequency. And what do you mean by frequency? The number of occurrence of repeating event per unit time is the frequency. In terms of waves, it's the number of waves passing a given point per unit time. And the unit of frequency is hertz, and f is equal to nu by lambda. And we all know what about the velocity, the speed of something in a given direction. The formula for calculating velocity is v is equal to d by t, that is distance by time. Now we can go to the derivation of the Doppler effect. I invite Aswathy to deliver the same.
Hope you all can see the whiteboard. Now, as
Yes.
Deepika said, Doppler effect is the apparent change in frequency due to the relative motion of source, listener, or the media between them. So there are four different cases in the case of Doppler effect in sound waves. The first case is source moving, observer stationary. For that, we have to consider a source S. Can you see the board? A source S.
Yes, we can see.
Moving with a velocity Vs. And it is emitting, the source moving with velocity Vs is emitting a wave having velocity V. And now, by the Doppler effect, if the source is approaching the observer, the Doppler shift nu is equal to nu 0 into V plus Vs by V. This is the Doppler shift in the case where the source is approaching the observer and the observer is stationary. Where nu 0, this term nu 0 is the frequency of the wave when the source and observer are stationary. Hope you understand this. And the second case, where the observer is moving, source is stationary. For that, we can consider the observer is moving. So let the observer be moving with a velocity VO towards a stationary source. Let V be the speed of the wave emitted by the source. So here the Doppler shift will be nu is equal to nu 0 into V minus V0 by V. Here nu 0 is the frequency of the wave when the source and the observer are stationary at the initial time. And the third case, where both the source and the observer are moving. Here, consider the source S moving with velocity Vs. Since in this case, both source and observer are moving, the observer is moving with the velocity Vo. And let V be the wave speed of the wave emitted by the source. So here in this case, the Doppler shift nu is equal to nu 0 into V minus Vo by V. This is the third case. Here, the Doppler shift is calculated for the case where both the source and the observer are moving. And this is all about the Doppler shift in sound waves where source and the observer are moving. In the first case, only the source is moving, and in the second case, the observer is moving. These are the three cases in Doppler shift. Now we can move to the applications of Doppler effect.
Okay. Now you have seen what is Doppler shift and the different equations, that the four cases where you can calculate the Doppler shift in different cases. Now we will move on to the applications of Doppler effect. Doppler effect find its applications in many fields. First of all, we will be seeing the application of Doppler effect in the nature. Okay, the first application is that the one application of bats, that is when one application of Doppler effect is found in nature, that is occurs in bats for hunting their prey. We all know bats hunt their prey with the help of this effect. Bats navigate its flight by emitting whistles and listening for their echoes. They will emit this and they will listen for their echoes. When that echo will reach the bat, they will be identifying the speed of their prey and they will adjust their speed accordingly. That is the first application. That is when chasing the prey, its brain detects a change in the pitch between the emitted whistle and the echo it receives. As a result, it tells the speed of the target. The bird, that is the bat will be identifying the speed of the prey and hence it can detect where it is. Now moving on to the next application, that is radar. Okay. The Doppler effect is used in some type of radar to measure the speed of detected objects. It is used in radar to measure the speed of the detected objects. For example, a police officer uses radar guns to check for speeding vehicles. They will be using it to find these vehicles with over speeds, and radar gun emits wave at a particular frequency, which when strikes the vehicles bounce back towards the gun. Hence, they will be identifying the speed of the vehicle. And the next, the radar gun measure the frequency of the returning waves, then eventually determining the speed. That is when radar guns will pass a wave, they will return back to them, and with that they will be identifying the speed of the vehicle. Next application, that is Doppler radar. That is, it is a form of technology used for only law enforcement officers, but also by the meteorologists. They utilize this Doppler effect to determine the direction and velocity of raindrops, wind direction, and other weather events. Using Doppler effect, we will be identifying the velocity of our raindrops, the direction of the wind, and the weather events which is happening in our nature. This principle is very crucial as it allows the meteorologists to predict weather pattern, including coming storms, that we will be able to detect the storms which will be going to come and give an according alarm for that. Now, the application of Doppler effect in medical diagnosis. Physicians and medical technicians apply Doppler effect to measure the rate and direction of blood flow in a patient's body along with ultrasound. We will be saying that Doppler effect today we are dealing is with the sound wave. So it is associated with the sound waves, Doppler effect and ultrasonics. So ultrasound beam are pointed towards an artery and the reflected waves exhibit a shift in the frequency. Because the blood cells are acting as moving sources of sound waves, we will be able to apply this Doppler effect in them. An echocardiogram uses sound waves transmitted by the ultrasound to produce images of the heart, and we will be identifying the problems and what is the problem, the doctors will be able to detect it. That is the application of Doppler effect in medical diagnostics. Next, we will be moving on to the application of Doppler effect in satellite communication. Satellite employs Doppler effect in its tracking techniques for determining the distance between the satellite and the receiver at the time of closest approach as well as the time itself. We will be able to identify the distance between the two satellites. Approaching satellite increases the frequency related to the actual transmission frequency, and as it retreats, the frequency is lowered. At the time of the closest approach, the transmitted and the received frequencies are usually the same. So, Doppler effect finds its application in satellite communication to find its distance between the satellites. Now, Doppler effect has also its applications in other fields like astronomy, vibration measurement, to sense the gestures. That is, it's a computer based to just we will be dealing with the computer based gestures. Then we will be detecting different type of audio and velocity profile measurements. So these are the main applications of Doppler effect. Hope you all have understood this topic. Now we will move on to the review questions. So we were dealing with the Doppler effect, and the first question is, what is Doppler effect? We all discussed the answer, so we will be able to identify what is Doppler effect. The next question is, write down the equation for finding Doppler shift. We have discussed three different situations for Doppler shift, and so you can write the different equations for the different situations we calculated. Now, the follow-up activity is find out more applications of Doppler effect. You can find out more applications where Doppler effect is employed in finding out something. And the second one is explain flow measurement. This is a typical term which will be associated with a Doppler effect, and you can explain this term. So that is all for today's session. Hope you all have understood the topic Doppler effect. Thank you all and have a great day.
Thank you.
Thank you.